In this video, I'm going to solve two practice problems with you on your uncertainty homework. Don't forget your name at the top and know that relative uncertainties mean percentage or fractional uncertainties. So I'm going to solve 5C first. 12.02 plus or minus 0.08 centimeters, and I'm squaring this measurement. Now, a lot of students will just square this and square the uncertainty and get the final answer. But that's not how we calculate the uncertainty in 12.02 squared. The data booklet tells you what to do to calculate the error in 12.02 squared. So in the data booklet, this would be my A, my measurement, and this is my delta A. If I grab the data booklet, it says right here, if you're raising your measurement to a power, in this case I'm raising A to the second power, then the uncertainty, the percent uncertainty in 12.02 squared is 2, the power that you're raising 12.02, which is 2 times the percent uncertainty in 12.02. 2 times 0.08 divided by 12.02. So I'll get the percent uncertainty in 12.02 squared equals 2, because that's the power, times delta A, 0.08, divided by A, 12.02. This becomes, I'll plug it into the calculator, 2 times, I'll open up parentheses, 0.08 divided by 12.02, and I get 1.33%. 1.33 e negative 2. 0.0133. That is the percent uncertainty in 12.02 squared. I'll get 12.02 squared, it's around 144. So 12.02 squared equals 144.48. I'm going to round this to 4 sig figs, or to 1 decimal place of precision. And now 1.33% of this number is uncertain. So I'll multiply by 0.0133. Which gives me an answer of 1.9 for the uncertainty in 12.02 squared. So my final answer, I'll write it up here, will be 144.5 plus or minus 1.9, the units, centimeters squared. Okay, notice I have 1 decimal place of precision here in the measurement or the calculation, and this matches the precision of the uncertainty, 1 decimal place of precision. Okay, let's do one more. We'll do number 6D. This is a good one. 4 pi squared divided by 0.034 plus or minus 0.004 seconds squared per centimeter. This is a constant. I'm dividing a constant by a measurement that has an uncertainty. The constant has no uncertainty, so the percent uncertainty in the resulting calculation doesn't change. Just like we saw in going from a diameter to a radius. Multiplying, which is the same, dividing, same thing, by constants, keeps percent uncertainty the same. Don't forget it. Okay, so I will go ahead and get the percent uncertainty in 0.034. I'll take its raw uncertainty, 0.004, or its absolute uncertainty, and I'll divide by the measurement itself. 0.004 divided by 0.034 gives me around 10%, 0.1176. That's like 12% uncertainty in this measurement. So now I can do the calculation. 4 pi squared divided by 0.034. 11% of that is 11.76% of that is uncertain. So I now have 4 pi squared divided by 0.034, and I'll carry the units. That's second squared times centimeters to the minus 1 per centimeter. That's like saying this, second squared times centimeters to the negative 1. So I'll do 4 times pi squared divided by 0.034 gives me 1.16 E3, and 11.76% of this is uncertain, so I'll multiply this by 0.1176. Gives me this answer. Gives me an answer of 136.6. So my final answer becomes 1,161. Okay, I'm looking back at the calculator to get the extra decimal place. Plus or minus 137. So I'll round this up because the percent uncertainty doesn't change. And then my units become the inverse of all of this. So I'll multiply all of these units by -1, or I'll raise all these units to the -1 power, so I get centimeters times seconds to the -2, and this is my final answer. Thanks for watching, and I hope you found this video helpful.